Here I have a class called myClass. It has a simple constructor which just prints constructor. The constructor is called when an instance of myClass is created. The opposite of a constructor is called a destructor. Here is what it looks like. It doesn't have any return type, and its name must be tilde followed by the class name. The destructor is automatically called when an instance of myClass is destroyed. Let's make it print destructor. In main, I'll create an instance of myClass. This calls its constructor, and then when main ends and the instance goes out of scope, its destructor is called. So if I start the program, you can see exactly that. The same thing happens in a regular function. So I'll just get rid of this instance and then create a function called if. The only thing it will do is create an instance of myClass. Back in main, let's print before if, then call the function and print after if. If I run the program, you can see that both the constructor and destructor for myClass was called. An instance was created inside if and then destroyed when the function ended. Great. Now let's try to allocate an instance of myClass on the heap using new. If we forget to delete this pointer and just run the program, we see that only the constructor is called, not the destructor. But if we delete the object as we should, then the destructor is also called. Okay, now we know what a destructor is and when it's called. But why write one? You must write a destructor when your class acquires some kind of resource that must be cleaned up when it is destroyed. The typical example is memory allocated on the heap using new. So let's give this class an int pointer. And in the constructor, we will allocate memory for it using new. This memory must be deallocated or freed when the class instance is destroyed. So we should do that in the destructor. That's of course just one example. If your class owns a file handle or network socket that must be explicitly closed, then you should also do that in the destructor. Most of the time though, you don't have to write your own destructor. If your class just stores some primitive member variables like integers or booleans, then you don't need to write a destructor. These member variables will be cleaned up automatically. But what about class member variables which themselves allocate memory using new? Our class could, for example, store a vector The vector allocates memory internally using new, but we still don't need to write a destructor. The compiler will generate a default destructor for us. This destructor simply calls the destructors of all member variables, in this case, the vector. You only have to write a destructor when your class owns some resource that must be cleaned up. Again, that could be memory allocated with new, or a file handle that must be closed explicitly. Now let's assume that this class actually needs a destructor. Should we then call the destructor for the vector here? No. You should never, well, almost never, call destructors explicitly. The destructor for the vector will still be called automatically in this case, so don't worry about it. The only thing your destructor should do is clean up any resources owned by your class directly. I will end this video with a recommendation. Writing destructors is not that easy. You also have to consider what should happen when your class is copied or moved. In most cases, you can and should avoid writing your own destructors. Instead of allocating arrays using new, use a vector. And if you need a pointer, use a smart pointer. These objects have their own destructors defined, which means you don't have to do any manual cleanup. I hope you now have a better understanding of destructors in C++. Thank you for watching.